function and points where extrema occur. In finding critical parts of an equation, take its first derivatives and equate it to zero.
Hello everyone, my name is Duane Guyala and I am from Group B STEM C.
Hello, I am Padillo from Group
Hello everyone, I am Irish Nuñez from Group G.
Hi everyone, my name is Geoffrey Espiritu from Group 3.
Hi, my name is Jhay Ibajo from Group B.
Hi everyone, I'm Joshua Laresma from Group 3.
For the first equation, we have f of x is equal to x cubed minus 3x plus 4 at negative 3 and positive 4. Now let's get its derivative. F prime is equal to 3x minus 3. Then let's equate 3x minus 3 to 0. After we equate it to 0, we need to transpose the negative 3 to the other side. It will give us 3x is equal to 3. Then over it to positive 3, so we can cancel it. And we get x is equal to positive 1. To get the maximum and minimum point, we have x at negative 3, positive 1, and positive 4. Then we substitute it to our equation. We have negative 3 cubed minus 3 times negative 3 plus 4. Then solve it. Negative 3 raised to cube is equal to negative 24 minus 9 plus 4. Negative 24 minus 9 plus 4 is equal to positive 32. Let's now move to the second one. f of 1 is equal to positive 1 raised to cube minus 1 plus 4 is equal to 1 minus 3 plus 4. F of positive 1 is equal to positive 2. For the third and last one is we have positive 4. 4 raised to cube minus 3 times 4 plus 4. (64 minus 12 plus 4). Is equal to positive 56. After we complete the table, we now can identify the maxima and minima point of our equation. After we get its derivative, we equate it to 0. We have 12x plus 12 is equal to 0. After we equate it to 0, we transpose the positive 12 to the right side. So we have 12x is equal to 12. Then divide both sides by 12 to cancel, and Leave the left side with x. Now for the final answer, we have x is equal to positive 1. To get the maximum and minimum point of this equation, we use this table. For the x, we have negative 1, positive 3, and positive 4. Then we substitute the negative 1. We have 6 negative 1 squared plus 12 negative 1 minus 4. Then 6 negative 1 minus 12 minus 4. We have 6 minus 12 minus 6 minus 4. And for the final answer, we have negative 10. The second one is 6 3 squared plus 12 3 minus 4. 36 plus 36 minus 4.
And for the next one is we will having 6 3 squared plus 12 5 minus 4.
For the final
36
answer,
plus 36 minus 4.
68. For our last substitution, we have positive 4. 6 times 4 raised to squared plus 12 times 4 minus 4. 6 times 4 plus 48 minus 4. 96 plus 48 minus 4 will give us positive 140. Now that we complete our table, we can now identify its maxima and minima point. Now let's have this equation. Y of x is equal to x plus 4 cubed minus 2 at negative 3, 0. Now let's get its derivative. Three times x plus 4 raised to squared Three times x plus 4 squared is equal to 0 over 3. Then cancel. X plus 4 cubed equal to 0. Then square root both sides. X plus 4 is equal to 0. Then let's transpose the positive 4 to the right side. We have x is equal to negative 4. Now let's identify its maxima and minima point using the table. For the x, we have negative 4, negative 3, and 0. Then substitute it to our equation. G of negative 4 is equal to negative 4 plus 4 square cube minus 2 is equal to 0 raised to cube minus 2 cancel equal to negative 2. For the second one, we have y negative 3 is equal to negative 3 plus 4 raised to cube minus 2 equal to 1 raised to cube minus 2, and for the final answer we have negative 1. For the last substitution, we have g of 0 is equal to 0 plus 4 raised to cube minus 2 equal to 4 cube minus 2, 64 minus 2, and for the final answer we have positive 62. After we substitute our x's to the equation, now we complete the table, we can now identify our maxima and minima point. For the equation x squared minus 3x minus 3, first we get its derivative 2x minus 3. After we get its derivative, now we equate 2x minus 3 to 0. After we equate it, we transpose negative 3 to the right side. That will leave us 2x is equal to 0 plus 3. Then divide both sides by 2. Cancel, cancel. We have x is equal to 1.5. Now for the maxima and minima point of our equation, we have negative 1 squared minus 3 negative 1 minus 3, 1 minus 3, negative 1 minus 3, 1 minus 3 minus 3, and the final answer is negative 5. Now we have positive 1 squared minus 3, positive 1 minus 3, positive 1 minus 3, 4 minus 3, now we have the final answer of positive 1. For the last one, we have positive 2 squared minus 3 positive 2 minus 3, equal to 4 plus 6 minus 3, then 10 minus 3, then we have the answer of positive 7.
The next example is y is equals to 4x squared minus 24x plus 6 at 1 and 4. The first step is to find the derivatives of the given equation, which is 8x minus 24. To find the value of x, equate the derivatives of the given equation to 0, then transpose negative 24. Then, divide both sides by 8 to get the critical point, which is 3. Now that we completed the value of x, the next step is to find the value of y. Substitute the value of x to the given equation and solve. Y is equals to 4 times 1 squared minus 24 times 1 plus 6. Then solve. you'll get y is equals to negative 14. Substitute again the value of x to the given equation. Y is equals to 4 times 3 squared minus 24 times 3 plus 6. Then solve. You'll get negative 30. Substitute the last value of x to the given equation. Y is equals to 4 times 4 squared minus 24 times 4 plus 6. Solve. And the value of y is negative 26. The maximum point of the given equation is 4 and negative 14, while the minimum point of the given equation is 1 and 30.
Now let's have y is equal to 9x squared plus 11x plus 8 at positive 1 and positive 5. First we get its derivative. Y prime is equal to 18x plus 11. Then equate 18x plus 11 equal to 0. 18x is equal to negative 11. Divide both sides by 18. We have x is equal to negative 6, negative 0.61. Then let's get its maxima and minima point. For the x we have negative 0.61, positive 1, and positive 5. And for the y we have 1.14, positive 28, and positive 285. We have f of 0 is equal to 0 raised to 2 minus 4 times 0 plus 3. We have 0 minus 0 plus 3. And for our final answer, we have positive 3. For the last one, we have f of 2 is equal to 2 raised to 2 minus 4 times 2 plus 3. 4 minus 8 plus 3. And for the final answer, we have negative 1. Now that we complete our table, we can now identify the maxima and minima point of our equation.